Right, I'm going to start now before you guys scroll all the text off screen so I can't see who's joined. Hi to Andy, hi to Stepz, hi to Prince Phase, hi to Amat, hi to DMX87, to Stepz, ZX Becky, Prince Phase. I see I'm repeating because I'm having to scroll through. Andera64, welcome to the stream. Oh, you've made a SID request. I'm going to reject that and get you to do it again because I want to test something in a minute. So, who else have we got here? Mr. G, Colt. I've probably missed somebody because I'm having to scroll through all the all the gambling. All right, so let me start by just. Hopefully, you can hear me, by the way, guys, and hopefully the music's not too loud. So let me just reject that request, and if you make another request, Andira, I just want to see if it works because I did a little something today. SID requests are down to 400 as well. So I'm finishing off the wine from the weekend. Go on, get that SID request in. Okay, well, when you want to undo a C64, if you make that same request again, I'll stick it on. I've added a little audio alert for the SID requests, so I can kind of hear when they come in. As part of my stuff for the giveaway, I've kind of been looking into using Twitch pub sub system to monitor things. Cool, there we go. No, it's because the chat that I have doesn't tell me that it's a request. All I see is what you type. So all I see is Master of Magic. I just see this basically. So that was the request, but it doesn't show up as a request. It just shows up. So now I've got a little text to speech and a little scroll across the screen. Right, let's put that on. I'll explain what we're going to do. So tonight we're going to do, or we're going to attempt to do, a rotary Starfield. I've never done this before, so I have no idea if this is going to work. I think it will. I don't see any reason why it wouldn't. No, we're doing a rotating Starfield. We've kind of covered the Starfields in the episode that we did with the rain as well. That I showed you how to do use the same technique for doing Starfields as well. So you should be able to use that technique, but this technique could still work for rotating, but we're specifically going for rotating Starfields tonight. So if you look at a normal character screen like this, it's 1000 bytes, it's 40 across, 25 down, and each byte represents, each square in this grid represents one single byte that is drawn to the screen, and this byte is a reference to a character in the font from 0 to 255. So this screen takes 1000 bytes, and this is character mode, which means you have 256 unique tiles, if you like, that you can put around the screen. But obviously that's quite limiting when it comes to doing something like a Starfield. You make the debugger windows big. So the C64 has bitmap mode. Not all 8-bit machines have this. Most of them you have to kind of put characters on the screen and do it that way. There we go. Trying to keep up with chat as well. So bitmap mode on the C64 works fairly similarly to character mode, but instead of a single byte for each one of these squares, there are 8 bytes for each square. So just like with a character in the font, consists of 8 bytes that define each row. It's the same with bitmap. Bitmap, basically the order is exactly the same. You go from top left to bottom right, going from left to right for each row. But instead of 1 byte for each position, you have 8 bytes for each position. So each position on the screen has 8 bytes that define the rows that would make up a character in that block. Basic coding imminent. So what does that mean? That means that, first of all, it means that it takes a lot more memory up. So this screen takes up 1000 bytes and an extra 1000 bytes for the color. But a bitmap screen takes up 8000 bytes because it's the same layout, but there's 8 bytes per grid square, basically, per screen kind of location. Additionally, you use the screen RAM and the color RAM on top of that. So there's 8000 bytes for the actual bitmap. Then there's another 1000 bytes, which is the screen RAM, and this defines 2 colors. So the lower nibble defines the background color, the upper nibble defines the character color, and then there's the color RAM, which defines another color on top of that as well. So you can define 3 unique colors for each grid square on here as well. So is that right? Or can you define 4? No, I think you can define 3. I think you still use the background color as well. So you actually define, so you've got a background color, then you define 2 other colors in the screen RAM, you define 1 color in the color RAM. We're not going to bother too much with the colors tonight. I will demonstrate a little bit how to change them, but what we're going to try and do first is show you how to set the bitmap screen up, how to turn it on basically, how to write a kind of character to it, and I will quickly just demonstrate how to change the colors of that one character on the screen. Just trying to think now. Yeah, you can define, I can never remember with the colors, but we'll go into it anyway. But in high res mode, it's essentially you use the screen RAM to define the colors of the bits that you're using. Okay, so let's start by turning on bitmap mode. So bitmap mode is turned on in D016, I believe. Right, it's just on a random play now, I think. Actually, it's not a random play, it's just going through whatever this is. Let me go back to what I was on before. So the reason why you don't get bitmap mode used quite that often in games is because it does take up half of your VicRAM. So oh, you didn't get any text to speech there that time. I'll read it out then. F me, I can actually hear the music tonight. I better request a Sid. Okay. Thanks for the bits, Hayes. you'll be happy to know that there is now text-to-speech when you request a SID as well. I think the text-to-speech in Twitch is a bit screwed at the moment, actually. Or in Streamlabs, whatever it is that does it. It's Streamlabs that does it, isn't it? Yeah. I think there's something a little bit wrong with it at the moment. I don't know what they've been doing, but they've definitely broken some stuff. Okay, right. I was looking up what the... or is it D016? I believe it is. I just need to double check. No, I was wrong. D011. Okay, right. So D011 is where we set whether or not we're in text mode, bitmap mode, extended background mode. We also turn the screen on and off, and we've also got setting the screen modes to 25 or 24 and the vertical raster scroll. Now, the default value is normally 1 being there. And all we need to do basically to turn on bitmap mode is to turn on bit 5. So bit 5 would basically make this 3B. There you go, that's bitmap mode. So if I just run that, you should see the screen looks a bit odd. Why is that not loading? Oh, that's a bit weird. Why is it not loading? Maybe I need to turn that off. Ah, there we go. Okay, so you might say, okay, this kind of looks like character mode, and the reason it looks like character mode is because the bitmap is using... so there are 2 locations for bitmap. So with screen RAM, with character RAM, there's many more. So screen RAM, there are... trying to count how many there are now in my head. 16 different locations for screen RAM. And with character ROM, there are 8 different locations because of the size of the character bank that you're using and the number of positions in a 16K bank. With bitmaps, there's only 2 possible locations. So there's one that starts at the beginning of the current bit bank and one that starts in the middle of the current bit bank. And the default is it will start in the middle, at the beginning of the current bit bank. So what we're seeing here is memory address from 0 up to 2000, which means we cross the boundary of where character ROM is. And as I've said before, with the VIC, whenever it reads the addresses at reads the data at 1000 to 2000, it will always see character ROM. So this is no good for a bitmap screen. So we're going to move that now. So that's basically D018. So we need to we'll keep our screen at the same location, which is that, and we'll move the VIC bank for the we'll move the pointer for the bitmap up to the second bank. Should be that, I believe, and we should see something a little bit different this time. Yeah, first or second half. Yeah, exactly. There we go. So we've got something very different there. So what you can see now is you can see some colors where the original text was, and that's because the screen RAM in bitmap mode is being used for colors. So if we just fill the actual bitmap in, so we'll do it here. I mean, you wouldn't probably do it like this. You'd either have something loaded already or you'd have a routine to fill it, but we can fill it like this for simplicity's sake. So I'm just going to fill it with zeros, and you'll see that all we have left on the screen when I've done this is the colors that represent the kind of the basic ROM startup. So there you go. So you might be tempted to think that's color RAM, but it's not color RAM. It's actually screen RAM at this point. So I'm gonna make 2 labels here just so we know what we're using. So we're gonna keep screen RAM at 0400, but we've moved bitmap RAM. Whoops. We've moved bitmap RAM up to 2000. So what we need to do to clear that is we need to put some values into screen RAM. Show you how these colors work in a second. So yep, so I'm going to store that at screen RAM. There we go, we've got a black screen. Now, if I change that value there to, oh, sorry, not that value. Closed, god damn you. If I change that value there, you see now we've got a white background, and that's because this value that we draw into ScreenRAM defines the color. It actually defines two colors. This bottom one defines like the background color, and this one defines the pixel color. So we're going to change the background color to gray just to demonstrate that that's what's going on. And you see it changes there. So before we continue, I'm going to show you what I mean by drawing something into the bitmap. So if we take the value FF, that's a full line of 8 pixels, and we store that at bitmap RAM. It's going to be really hard to see this, but actually you can just about see it there in the top corner. You can see we've got a full line here of 8 pixels. So you might think, okay, I want to do another line of pixels next to it, or I'm going to skip a bit and then do another line of pixels. But watch what happens, and this is what I was saying about the layout of the bitmap you need to get used to. So this line is now below it. So you think, okay, so maybe it's going all the way down the screen, right? So if I did +8 here, it would be a bit further down. It's still not the case, unfortunately. Let me see, there you go. So it's drawing, what it's doing is it's basically, in the same way that the screen goes from, as I said, from left to right, from top to bottom, the bitmap works exactly the same way, but it always draws eight small sections of 8 pixels at a time. So it basically fills in one character block at a time and then moves across. I mean, it's probably done for speed purposes, and simplicity purposes on the chip, but it does make it a little bit awkward. So what I'm going to do is I'm going to show you how we can grab that address. So I'm going to create a function here now. So functions work a lot like macros in Kick Assembler. You pass 2 parameters in and they return a value. So we're going to return an address. And to get the X and the Y, what we need to do is we need to first of all work out what column and what row we're in. Because we need to work out from, let me open the debugger. I don't know why I've got 2 versions of the debugger, but I do seem to have 2 versions. So given a Y position, we need to work out which row we're in here first, because we need to work in rows and columns. So to work out what row we're in is quite simple. We take the Y value and we divide by 8, floor it. So that means if we're in a Y position of 0 to 7, it'll be this row, and so on all the way down. And the same applies for the column as well. So column is exactly the same thing, but with X. So that gives us our rows and our columns. Then we can use this to calculate the address now. So the address is actually, if we take whichever row we're in, each row has got 40 characters of 8 bytes. So our address is going to be the row times 320, or 40 columns times 8 bytes, 320. So I'll do it like that, so it makes more sense. Then we need to add column times 8, because each section in here is 8 bits apart, 8 bytes apart, plus, and this is where we need to do something a bit funky, we need to get the row that we're in, times it by 8, and minus Y. The reason we have to do the row times 8 is because we basically need to work out this, which is the leftover bit in Y, basically. And because we're doing a divide by 8, we'll need to times it by 8 here. And that should give us an address, which means we can do something like this. if I did 16, so why is that not working? Oh, because at the very end I need to add the location of bitmap RAM, because this was just working from 0 to 0 onwards. We need to add the bitmap RAM so that we can get the proper location. And there we go. But obviously this is only giving us the row of bytes that we need to apply it to. So the next thing we need to do is also work out with another function what bits we need to change. Because otherwise we only have single pixel precision vertically, but horizontally we only have eight bits of precision. So to get that, we're going to do the same thing again. We're going to actually, we just need column here. I don't think we need row. And we're going to return a value which is going to be 2 to the power of, and then we need to work out our column times 8 minus x. So actually we don't need the y here at all, but I'm going to leave it in there just for symmetry. And also this needs to be 7 minus, because the first bit in the row is not 0, it's bit 7, so it needs to be flipped on its head the other way around. So then what you can do is you can do, okay, and I mean you wouldn't write code like this, but you'll see why I'm making these functions. So let's catch up with the chat a little bit. Move your graphics, high-res graphics area under basic. Yeah, it's a good idea. Thick emulation style. Yeah, sequential characters. Yeah, exactly. It's a strange layout indeed. Just how to it's better, I suppose. Atari ST use interludes playing to word at a time. Oh, really? Wow. Amiga is sensible by going full row right and then down. Are you logically? Yeah. I mean, that is the way. Is the way you would expect bit planes to work, right? Proper way to do them. Sometimes they're interleaves, so like on the Game Boy, even though it's tiles, the data is interleaved as well. So is this where we come to close the part where we use the pattern for quick bit access? Yeah, we do come close to that, but we're not gonna. I'm showing you how to work out where things are on the screen, and then we're going to build a table out of them as well. But yeah, I mean, it's always worth having a table of that anyway. I nearly always, in every program I do, I have a pop table, which is a power of 2 table, and it just contains literally just contains that, and sometimes I'll have an iPot table as well, which is an inverse one, and it'll be exactly the same as that, but 255 minus all of these. And these tables, small, 8 bytes each, but incredibly useful. Use them for anding and oring all over the place. Very powerful. You can use them for sprite, most significant bits as well. So if you've got a sprite, you know it's sprite number 7, and you want to set a significant bit, then you just look up the value you need to OR in here. If you want to clear its significant bit, then you look at the value you need to AND in here. So these are really useful tables to have, and yes, you would use these if you were doing a more generic kind of bit mapper blitter, then you would use those definitely. Okay, so what I'm doing here is I'm going to try and find a way to set these values. So what I'm going to do is I'm going to create a small loop in here, and I'm going to do this. It doesn't really matter how many times I do this actually. So I'm going to go for 360, one for each degree in a circle, even though pretty certain we use radians in here, but okay. And I'm going to create some variables. So x is going to be sine. So this is just the formula for a circle, basically. we're going to do it, let's do it times 90 plus 100. So this is the formula for a circle. This is your radius here, and this is your position, your kind of center position. And then I'm going to use these to look things up. So I'm going to grab the address of that. And I'm going to grab the bits for that. And now I should be able to load the value that's in address. I should be able to OR that value with bits and store that value in address. If I've done this right, it's going to generate a huge amount of code here, but if I've done it right, we should be able to see something on the screen. Okay, it's not quite right. Just trying to work out what I've done wrong. I've got my values wrong in there. Oops. Oh, I know why. Because that should be immediate mode, that's why. Still wrong though. Well, let's just try putting FF in first, just to see if we get a neat circle of lines first. Yeah, I thought I had mastered bitmaps, but it actually looks like it's doing something odd here. I'm not sure why. Have I done this the wrong way around? I think I might have got this right. No, I did check something before, so I did cheat a little bit and have a go at this, just the bitmap stuff. So I'm going to see if I can find it, and I don't seem to be able to find it, unfortunately. I don't know where the hell I put it, so that's good. Oh, there it is. Okay, that's what I should be doing. Let me check that against what I've actually written. It's call times 8 plus... Oh, it's this. This is the wrong way around, that's why. So I was supposed to be getting the kind of the remainder basically from this calculation, and I was basically doing the wrong way around. I was taking the value and then minus some y, so obviously it was going to be wrong. That's better. We've got something that resembles a circle, and if we get rid of this and turn it to bits instead, we should hopefully get something which resembles something. Okay, let me check my formula down here as well. Oh, damn it, I've also got that. Bits 7 minus x. Oh, I've done the same thing down there as well. God damn it. So likewise, that would be x minus, not the other way around. Okay. I don't know why it's. I mean, it's kind of working, but for some reason it's. I mean, if I didn't do, oh, because I've done load accumulator, it should be aura like that. There we go. There we go. Still wrong though. Okay, let me. I've had this working today, just for a circle, so I'm gonna keep referring to this until I get it right, and then we'll continue with the rest. Where have I put it? There it is. Yeah, that should be fine. I mean, I can copy these functions completely. So it's basically the same thing. Yeah, maybe it's just because I've not done that return. So let me copy those exactly. 7 minus x minus 5 all times 8. Okay. It could just be this shitty routine as well. I didn't do it like this today, so. I do need more wine, don't I? That's what it is. It's just getting strange values back from these. That's the... Like when it draws that, it should be a single bit, not this whole thing. But for some reason, it's returning a much different number. That's what I'd expect. Is it bits or bits? It has to be this because that would be an address. Otherwise, it's not an address. We need to OR it with a value. So I would be happy with that shit bit again. Bit location in byte is 7. Yeah, that's what I'm doing here. Column type. That's exactly what I'm doing here. So. Sure what? Because the address looks fine. X is that. Y is that. Address is that. Load the value that's currently at that address. OR it with that value. Store it at that address. And that should be filled with zeros all the way through. So I'm not sure what's going on there. I mean, just to give you an example. So this is what I did today. Similar thing. So I don't know why that's not working. But I used a table to generate this, so I'll maybe... hang on. I know what it is. The X and the Y need to be floored, otherwise you're going to be sending some very strange values into that function. There we go, perfect, okay. Yeah, so the problem there was I was sending non-integers into this function here. And obviously if you start dividing non-integers by integers, you're going to get different results than if you did it with integers instead. And obviously that's going to screw up these calculations and screw up our address and rows and stuff. And you know, adding a value in here. Yeah, we just that's why. So what floor does is takes a number and just removes the decimal component. So floor that is the same as 5. You probably see it as this in other languages. It's just basically taking a number and turning it into an integer. The annoying thing with it is if you've got a negative number. I think at least in JavaScript, I think floor works kind of a little bit differently with negative numbers. Let me just check. Yeah, so floor of that actually is -6, and it's because what it's actually doing is it's not just removing that, it's just going to the next number down from it. There is a counterpart to this called ceiling or seal, which basically gives you the number up from this, the next number, whole number up from that. So that's what floor and ceiling are doing. There isn't just a cast integer in Kick, so that's why I have to use floor and ceiling. Okay, right. So with that in mind, we can now draw a circle, right? So my idea for the Starfield is basically this. We're going to create some tables. We're going to create a whole shitload of tables, one for each angle that we want a star to come out at. So you can kind of think of it like, so if we had it like this, and this was one table, right? Actually, this wouldn't be one table. Let me do this. So let's say we do 32 positions, so 32 angles in the circle, so 32 kind of sectors, if you like. we are going to add one table for each of these positions around the circle, and that table is going to have a number of positions along it. So we're basically going to be creating lines that radiate out from the center. Is that not running? Okay. Oh, it overlapped. All right, so I need to move this up to somewhere different, because this is one hell of a big table, and it would be this big anyway. So, but, there you go. So what we've got here is we've got 90 concentric circles where each dot is 32 pixels apart from the last one. I don't know what that one is doing there. That's a weird one. That's probably because we've got position 0. I think if you put 1 on there, it's probably fine. No, all right, we've got a weird one there. Don't know what that's doing, but we'll work that out when we come to it. So my idea is that we're gonna position this in the center of the screen here. Oh, why can I hear that? I can suddenly hear the music in the headphone. We're going to move the center of this into here, and then we're going to create a line of stars that move out from the center to the edge of the screen, which means that the longest line is going to be from the middle to the edges here, the left and right edges, and the shortest ones will be here. But what we're going to do is we're going to record every line is going to be the same length. So all the stars are basically going to move along the same length of line. It's just when they reach the top edges, they won't be shown. And what we're going to do is we're going to create a table for each of one of these lines. So imagine this line here. We're going to have a star that starts moving slowly here, and then as it gets to the end of this line, the gaps between each plot are going to get bigger and bigger, so it kind of moves quickly off the screen. And that will create, just along that one line, that will create the illusion of a star moving slowly, then speeding up as it gets to the edge. Now we're going to do that on each one of the position around this, and then what we can do is we can define a star by its position along the line and the angle that it's being shown at, and then we can very quickly look up in the table where it should be drawn on the screen. So let's give that a try. Let's try. We'll keep this thing in for now. I'm just going to change the position of it and the size of it so that we can see what it looks like when we get stuff a bit closer. So closer to the final kind of view. So let me close that. It's weird how I can hear a bit of the music in my ear. So first of all, I'm going to change the step on this a little bit. So I'm just going to step it up to 3 at a time. I'm going to start it here. And we're going to start in the middle of the screen. So the middle of the screen is 160 across, but only 100 down. But that means our longest line is going to be 160 long. So 160 is going to be the final value. I'm going to make this a step of 4 actually. Let's do it like that. Now, what we need to do here is, first of all, if the address is outside the bound, so if x and y become, if x is negative, so we can do this here. If x is less than 0, or x is more than 319, then we're out of bounds, right? And so what we'll do is we'll just return the value of bitmap RAM. So it's going to be the very top corner. And I'll show you why we're going to return that value in a second. But for now, I'm just going to do this. So same with y. If y is less than 0 or y is more than 199, we're just going to return the address as the top corner. That's going to stop us from referencing anything outside of the bitmap. Then all we need to do here is in our get bits, we return 0 when we meet the same requirements. And that means when we try and draw to that position, it won't draw anything. We're just returning blank. So it will just, we don't have to deal with that case. It's handled by this routine. So some talk about JS, Jar bless script. JS is invented 20 years earlier, 602, so would have been JS instead. First experiment has been completed. Indeed, maybe one day we compose 6510 with a native JS chip. Some ARM cores of a technology called Giselle, where they execute Java bytecode natively. Oh God, I wouldn't like that. That would drive me mad. Yeah. And then Hayes is on his little emoticon mission. There's always something Hayes has got that no one else has got in those. It's kind of hilarious. Okay, so now if I run this, we should get something that fits in the middle of the screen. Okay, no problem. Danger Freak, cool. I really do like that SID thing. That's worked really well. You need to turn up that TTS. It's just on this, so I'm just using the JavaScript browser speech synthesis, so I'll find a way to turn it up a little bit. I was kind of experimenting with it tonight. Chris Hulsbeck. Oh, cool. I did kind of want it on a separate channel, but unfortunately when I try and add it as a browser, because I need to log into Twitch, I don't know how to log into something on a browser instance that's inside OBS. So, oh, that's a good point. The lines don't reach the board, and the reason they don't reach the board is because I've assumed this is the longest line, and it's not. The longest line is going to be from here to here. So actually, the longest line is not 160. It's going to be square root of 160 times 160 plus. Has requested JS is speaking to us. JS is speaking to us. Person raising both hands in celebration. Person raising both hands in celebration. Person raising both hands in celebration. Person raising. Okay, I'm regretting the text-to-speech stuff now. Person raising both hands in celebration. Person raising both hands in celebration. Person raising both hands in celebration. Well, I'm going to reject that because I don't have anything to add there. Why did I give Hayes another way to do text-to-speech? So yeah, we have to use Pythagoras to get the length of the longest line. Pretty simple maths, really. And that should hopefully give us... Oh, actually, I need to actually put it in here as well. Cool, there we go. So you can imagine if you pick a star somewhere along this line and then just rotate, it's gonna move around like this, and it's gonna move around slower in the middle, faster on the outside. But obviously, this isn't going to be how we do it, because this is taking a lot of memory up just to do this. The code that generates this. We're going to use tables to do this thing. Which is still going to use quite a bit of memory, but hopefully not quite as much as this. So, in fact, how many will it be? It will be 6, 8. It's going to be about a third as much as that. So this is using just under 12k. We'll probably use about 4k to represent the same thing as tables. Which sounds like a lot, but when you consider that how quickly we're going to be able to spin things around the screen, it should look pretty decent. And we can change the kind of length of the line as well and stuff. So, right, I'm going to wait for that until I've had a smoke. Oops. I actually bought today a floppy drive for my PC. Just so I can copy stuff to these things for my D81, because it's so slow to do it on the actual D81. So there's some decent software for the PC that allows you to transfer D81 images directly to floppies. So I bought a little USB floppy drive. Hopefully it works. But it's the first time I've had a floppy on my PC for maybe 25 years, maybe something like that. No, maybe not 25 years, maybe 20 years. But yeah, floppy drive for my PC. Weird. Right, I am going to take a quick break because I do need to go to the toilet desperately. So when I come back, we're going to generate tables that are going to give us all of these locations in a nice referenceable way, so that we can quickly look up, given us a star's position along the line and rotation, what pixel we should be turning on the screen. So I'll be back in 2 or 3 minutes, guys, and we'll do that. All right, right back. Thanks for the host, Sinlo, and thanks for the host, Hayes, as well. I've give Hayes another way to. Should I just consume his channel points for that? Ooh, it's tempting. I'm not going to, but I will say that if it does get too spammy, I will start. I'll either turn off the message from the text to speech and just say it's requested a SID, or I'll just start consuming the points. It's all good. Doesn't bother me. And you'll need those points for the giveaway as well. So, although you should have quite a lot, I think. I think most of the regulars on the channel should be able to get 3. Right. Do you know what? Just because I am going to make sure I'm in the right place. There you go. And just refresh that on my... Why is that not working all of a sudden? But you made me break it. God damn you. Now I've broken it, Hayes, because of you. You're fully to blame. If your username is that Banhammer, yeah. I was trying to turn off the text to speech, and instead what I've done is I've actually ended up breaking it. So if I do that, yeah. There you go. Cool. Yeah. So now when you request it, will just I will reject them. But now you'll yeah, it's off. But now if you request a tune, now it should only I'll show you. Some Okay, right. So we need to make these tables. So the trick with these tables is going to be working out.
C64 has requested a SID tune.
See, you spoil the fun for everyone, Hayes. You're like the naughty child in class.
Has requested a SID tune.
Oh, Mule, that's a good choice. All right, let's put that on. So the trick with these tables is going to be finding a way that we can access them really quickly. So the values that we're going to have is the angle and the position along the line. So we need to align these somehow in memory that we can read these quickly and easily. That's going to be m.u.e. I don't know which one it is. It's not showing up. Who wrote the tune, do you know? Roy Glover. Yeah, there you go. try to see if Twitch injection is possible. I've tried with a few. So I've had a play around in chat before. I actually tried it on Hayes stream quite a lot to have a go. I haven't found a way through. I'm sure there is a way to do it, Cole. Absolutely positive there's a way to do it. I just haven't found it yet. Okay, let me bring up. Right, after all that messing around. Right, so we need to figure this out now. So what we need to provide for every location on the screen is an address, which is 2 bytes. And a bit mask that we need to apply, which is 1 byte. So we've got three bytes for each location on screen that we want to reference. So if we do 32 positions around, that's going to be 96. So that kind of fits fairly nicely. We can expand that out maybe. So if we did an inverse bit mask as well, so if we wanted to clear it, we could use another byte there. And then if we did 32, that would be 128 exactly. Although we're not really going to need the inverse bit mask, but we'll do everything in pairs of 4. So what we're going to do is we're going to create, do it down here so it's in order. We'll do it at 4,000, and this is where our data is going to be. And basically we're going to do this same thing again, but we're going to do it down here. And we need to make sure this is ordered correctly. So what we need to provide is, first of all, a word with the address in, and then a byte with the bits in, and then also a blank bit. So this is now taking up 4 bytes. And then we need to work out how we're going to do it. So we're going to do it sequentially. It's going to be the rotational value. So that is this one, and then this will be our position. So this is kind of right. I'm going to change this though. So the way I'm going to make this work now is we're going to add. We'll do from 0 to 100. No, actually, how many positions? So if we've got, let's turn that music down slightly. Yeah, let me know what you find, Carl. I'd be really interested if you can find a way into it. Twitch does have a lot of information available through their kind of public API stuff. There may be some interesting information in there. Was that it for Mule? That was really short. I'm going to play it again. I almost missed it. It was so short. Thanks, Henderif C64. Thanks for joining the stream, dude. I'll see you again soon. Okay, let me close that down. So I'm going to say, so this is going to be 128 bytes for each ring of stars. So it basically comes down to how many positions do you want to supply. So if we want to use let's use 4K, right? So if we want to use 4K, that's going to be 32 positions. So let's make this 32. And now we need to work out a position along the line. So I'm going to use an easing function for this. I've talked about these a little bit before. I'm going to go out and try and find my easing functions and just use one of those for now, hopefully. Oh God. Formula 1 Grand Prix, okay. Do you know who that's biting now? I'm a bit. Oh, Formula 1 maybe. I'm seeing a lot of Formula 1s, but none actually called Formula 1 Simulator. Is that the one you mean? Let's play that one. Oh, that is a good tune, isn't it? That's really cool. So it's just clear my stuff on here. Just miss anything. Oh, my floppy has been spat. Awesome. Yeah, that is a good tune, actually. I like that. Catch up with my windows. God damn it, my windows are all over the place. So yeah, just a reminder as well, on probably not this Saturday, but the Saturday after stream, we'll be doing a giveaway. I've already got Sam's Journey coming, Sam's Journey on cartridge, so that'll be one of the prizes in the giveaway. I'm probably gonna look at other prizes as well. In fact, let me just do a little quick poll on here. Duration 10 minutes is the most I can do. Okay. Data bit. Okay, so I started the new poll up at the top. I just want to know what percentage of you guys that have a C64 have a working data set for it as well, because I want to know if there's any use in actually supplying tapes as well. Because if there is, then I'll do some bitmaps off tapes. You have 4. So yeah, if you have a C64, answering the poll up at the top, up there somewhere, wherever it is, over there, and let me know. If it's a sufficient percentage, then I'll give away tapes on stream as well. Okay, right, so yes, easing functions is what I want to add here now. So let me see if I can find my easing functions. God, where are they? They're in .cosmos, aren't they? Because what I'm going to do is I'm going to use an easing function to create the actual position along the line. So this value here, says J, is going to be actually grabbed from that. I need to figure out where on earth I put those functions though now. There they are. Okay. So we've got ease out bounce, ease in, ease out core. Okay, so let's have a look at the easing functions and pick a relevant one. Okay, it's looking pretty good for people with working tape decks as well. No means you don't have a way of running tapes on a C64. I only want you to answer if you've got a C64, because if you don't have a C64, there's no point you entering the competition. This is just whether or not it's worth supplying tapes as well as cartridges. Everybody who's got a C64 can run a cartridge, but not everybody's going to be able to run a tape. So a little bit of speech there as well. Okay, so we want something that starts off slow and speeds up. So I think it's ease out that we need, or is it ease in? Yeah, it's ease in. So we want something like ease in quad, I think was one we had in that list. Ease in quad is a bit too slow, I think. So let's check quartz. Ease in quart, that's perfect. Okay, so this is the function we're going to use. I'm going to stick this in here. And I'm just going to change this to be a function as well. And what this is going to do is we're going to pass in a position along the line as well. So we probably don't need length. That is going to be the position along the line. There we go. That means we don't need to do this. Don't need to do that. We just need to return this value. So I've just changed this to return a single value instead of an array of values. Goodbye, Tiny Small. Thanks for joining. Okay, thrust. God, which one though? Rob Hubbard's thrust. Okay, so this is what we need to pass into here, and this will be, we'll call this position, and we're basically going to grab a value, and so the start value is 0, the end value is 31, because that's what we see in here, and J is going to be our position along here, and then we're going to change this to position here. In fact, let's confirm that that looks right by just doing this here as well. So we're going to do the same thing we did before. So we're going to load the address, all the bits. I just want to see if this actually looks correct as well. Which means I do need to turn it off for a split second. I'll just do this test. There is an I variable. That's a very good point. Oh, very good point. I over D. So this is going to be the percentage. Okay, so this is actually going to be D over C. I think that's right. No, that's not right, is it? Oh, that's because we're doing the positions. Okay, so this should be like that. There we go. I think that's right. Let's see what that looks like. No, it's not right as well. So we need this value to go from 0 to 1 based on this value here. That should be there, that's why. No. Oh, hang on. I can print out the values that are coming out of here, so just got to get this little routine right. Once it's done, it's pretty easy. Okay, so those values are coming out of 0 all the way along. So I would expect these to move from 0 to 1. Am I using some floors in here somewhere? I am using floor, so I'm going to get rid of the floor. Do that up at the top when it's done. Okay, those values look a little bit better. And then that means up here I can do floor, and then this times the longest. So you can see that value's tweening from 0 up to 1, or close to 1. Probably do that actually. And 1 is the final one. There we go, perfect. So now you can see that the stars start close together and they get faster as they move out towards the edges. It's perfect, it's exactly what we want. Okay, sweet. By Johannes. Oh god, okay. Cool, so this is the formula that we need. That can go here, like so. And there we go. So we should be creating 32 tables of 128 bytes each. which should take up 4K. Thanks for the resub, Foray. Very much appreciated, dude. Hey, Chiz. And hey, Foray. I don't know if you were here before, Chiz, but hey anyway. Okay, right, so let's see how much memory that takes. Right, that's been reused, so I need to get rid of this code now. And that does indeed use 4K, so that's perfect. Thanks for the follow, Akrak for us. Welcome to the stream, dude. Okay, so with that in mind, we should now be able to create stars and move them around the screen. So I'm going to move this back down to where it was. I need for it to be up there. So let's give that a try. So let's imagine we've got a star, and we'll move it. We'll just do a single star for now. So let's have a star. Well, we'll call it X, but it's basically, we're going to use kind of radial coordinates here. So we'll start it at 0. So this value is going to move from 0 to 32, because that's what we've got in our table here. 0 to 31, in fact. And star angle. And this likewise can go from 0 to 31. So what we'll do, I'm going to create a little break here just so that it only runs once per frame. Let's put this next track on. Oh wow, that's a lot of things called sweet. Just copy his name in there as well. Oh no, I hasn't found it at all. Brilliant. There we go. Oh yeah, what was the poll? So the poll was to see how many people have working data sets. So when I do the giveaway, I can't see the results. Hang on, let me find the results in the thing. When I do the giveaway a week on Saturday, I need to know whether or not I can include tapes in that as well. So 10 people do have working data sets and 3 don't. So that's 3/4 of the people. Okay, so I'll include a couple of tapes in there. So I may put a copy of Luma in there, and maybe a few other Bitmap soft games as well. So I will have a look through their catalogue and pick out some decent games and add them to the collection. I think I'm going to add one more cartridge game and a couple of tape games. So it'll be a nice selection. There'll be 2 cartridge games, Sam's Journey and something else. I'm not sure what it's going to be yet. And maybe 2 or 3 tape games as well. So should be a nice haul for whoever wins. And I've changed the system so you can buy up to 3 tickets. It costs 2,000 channel points for a ticket. You'll be allowed to buy 3 tickets to enter. And then we'll do the draw live on stream at midnight. So that therefore people who are loyal, people who are regulars, will be able to have 3 times the chance of people who just come in for the giveaway. And if people join just for the giveaway, they're going to have to, in order to get enough points, they're going to either have to come via a raid to get a points boost, but they're almost certainly going to have to sub, follow, and be active for 2.5 hours as well. So yeah, good luck getting 2,000 points on 100 Twitch accounts. Right, okay, so this is only going to run once per stream. So what we're going to do is we're going to grab the value that's in StarX, and we're going to look it up. So what we need to do is we need to figure out where we are on this. So the first thing is the position, the angle. Hang on, is that right? Yeah, different angles. Okay, yeah, so we need the position. So the position is 128 bytes. So hang on, data stored in rings of 128 bytes. That will help me understand it. So the first ring is going to be the first 128 bytes. The next ring outwards is going to be the next 128, and so on and so on and so on. So the first thing we need to work out is which ring we're in, and that's going to come from StarX. So if we just load StarX, I'm going to create a temporary variable. What am I doing? This is where we're going to store the data here. So we need to take the value in StarX, and we're going to store that at star lookup, and then we're going to load 0 and store that at star lookup +1. Now, if we shift this value, times it by 128. So to times it by 128, we're going to have to... Actually, is there an easier way of doing this? Maybe the way to do this is to store it this way round and half the value instead. That's going to be the easiest way. So then what we're going to do is we're going to take the upper value and we're going to shift that to the left, and then we're going to roll the lower value. So that gives us our position, the ring position that we're after, and then we just need the angle as well. So what we can then do is we can load star angle, and this needs to be times by 4. So what we'll do is we'll shift it to the right twice, and then we need to add this value, the lower byte, and store that star lookup. Oops, I don't know why I've compiled it again, but I have. I just scrolled up, and then I need to load +1, add 0. Except we're not going to add 0. What we're going to actually add is going to be this value here, because this is the beginning of our star location. So in fact, I'm going to put star tables, I'm going to call it, and that's what we're going to add here. Star tables. So that should give us a location for the star lookup. Now it's quite a lot of code to do this, but what we would normally do with this is we would probably look up the positions, store them in another table, and then do the drawing all in one go. But for now, we're just going to draw directly to this position. So we are going to load X with 0, Y with 0, and then we're going to load star lookup Y. This is going to give us our address that we need to draw to the screen. So I'm going to draw that to like so. So I'm going to start with 0, and then I'm going to increase Y, and then I'm going to increase Y again. And now I should be able to just store that. I'm just going to store it directly in this position for now. So I need to set Y back to 0. Okay. Right, so what I'm hoping to see here is a dot in the middle of the screen. If I see that, then things have gone right, which I have. Okay, cool. So just to make sure that this is working, what I'm going to do is I'm going to increment Starx, and then I'm going to, just to make sure it wraps around properly, I'm just going to AND it with 1F. This is going to keep it in. In fact, I could probably just do add 1. It's probably easier.
Muffin has requested a Sid tune.
Rob Hubbard 1-on-1 Jordan versus Bird. Okay. No idea what that is. Jordan versus Bird. Okay. One. Oh my god, there's a lot here. Okay, let's do Jordan. That's probably easier. I was trying to find a way to automate the SIDs as well. So I might find a way to do that, because I'm guessing these tunes all have IDs. So if there's a way to launch it via an ID, there might be a way to do this. So I'm also gonna start by making sure that before we start this loop, I'm just gonna put oops. Just so we've got a value to begin with in here. And the reason I'm doing that is because the very first thing I'm going to do is I'm going to clear the byte at that location. Okay, so I'm hoping what I see now is something kind of moving along that line. If we do, I mean, it's quite quick, so we might want to change the easing on this because it's a bit too slow at the beginning. So let's have a look at easing quad. I think easing quad is just 1 less on the T times T. Okay, yeah, so we just need to reduce that number here. Let's get rid of that. There we go. Well, it's moving very fast, but you can kind of see it. So now what we can do, with a bit of luck, is if we just do exactly what we've done here, but with start angle. Okay, I'm not seeing any change to the position. Okay. Okay, that's a bit weird. We should definitely be seeing some change here. Okay, let's get rid of that. Let's just change the angle. Okay, so I don't see anything when I change it. Okay. So let's try manually changing these values here. So, oh, I can see the problem because that should be times by 4, not divide by 4. Should be okay. So let's try it with a different angle again. Cool, so you can see that moving out. And we can mess around a little bit with this as well. So actually, I think it might be worth increasing the amount of positions to 64 instead. So we change this around a little bit. That will stay the same, but it does mean that this changes a little bit. We actually don't have to do this anymore, so that makes that a bit easier. So yeah, we just star lookup 1 becomes the position along the line, and this one becomes the angle, and then the value in here can be handled with 3F instead. So let's do the same with that. Start angle. It's moving so quickly it's hard to tell now, so let's slow this down a bit. So let's put a timer up here as well, I guess. Is that finished now? Yeah, okay. Let's have a look at demos and stuff. Shuffle. I don't know what these are, so I don't know if they're showing up on the show. Hopefully they're showing up still, yeah. Let's call this timer. And we'll increase this every time. And then we'll do the same thing that I normally do here, which is timer. Okay, the rotation is happening incredibly quickly, so we would probably do something similar here, where we only rotate every 16 frames or something. Yeah, that's happening every time. Why is that happening every time? Am I doing something stupid here? Seems to not compile it. Seems to still be doing the rotation. I think I've got my stuff wrong. Hang on. Oh no, okay, so I was kind of right the first time. Maybe we should switch these around actually. So we do lines of 256 bytes instead. Basically, I need to switch these around. Still moving too quickly though. And I'm not rotating the angle, so something weird has gone on here. So, oh, because now I'm grabbing. Okay, so we're storing a line at a time. So the highest byte is going to be the ring. So this actually needs to be times by 4. This is the position along the line. And then this actually needs to just be so believe. Hang on, let me think about this. So yeah, it's going along the line, along one line. Yeah, I know, sorry. I mean, with this stuff, it kind of is compiling as well, so it's kind of a bit of both, really. Hitch just shaved his beard off live on stream as well. Wow, okay. Crazy man, crazy man, crazy man. Okay, so this, let me just get this right. Okay, so X and Y comes from that, yes. So positions along, yes. Okay, so this star X should be times by 4, yes. Stored in the lower byte, yes. Take the angle, add it to star tables, and then look that up. That's going to be an 8 kilobyte table, yes. Okay. So why is it rotating? It shouldn't be rotating at all. Oh, it's not. There you go. It does disappear now and again, though. That's weird. Oh, because the angle should be 1F. That's why. So there's quite a jump between the angles, but I'm thinking with a lot of stars in here, it's probably going to look okay. So it's a charity thing. Oh, cool. Wish they had clear and I'd yeah, it is kind of annoying that they do have it in 6502. I think, do they have it in 4510? Maybe they do. I'm not sure. I don't think they do actually. Okay, so I'm not that happy with the movement, but I want to see what happens when I've got lots of stars in here. So let's go ahead and, well, first of all, let's see how much processing time this is taking. So let's turn the timers off, so it's just full speed. To here. So I suspect this is going to be quite slow. It's not too bad. So one single star takes that much time, so that's not that bad. Okay, so let's put a max stars. Yeah, okay, so now we're gonna try. We'll start with 32 stars, and we'll work our way up to more and more. So yeah, changing the angle every time. Yeah, so I mean we're not going to do that in the final one. We'll make that controlled by joystick maybe, but for now I want to do some tests. In fact, we can remove it now because we're gonna actually supply lots of angles and stuff in here. So star X is going to be max stars, a random number times position 30 times 64, and then floor that. And angle will be the same but 32. So here we can do load X with max stars -1. And now whenever I look up a star, I'm going to look up comma X. So this is going to fail actually, because we need to look up the current position and then remove it. So we're gonna have to change this slightly. So I'm gonna get rid of this. I just want to see how long it takes to draw these stars first. call it starving. So this is just going to draw all the stars basically along their lines. So we'll probably get a similar pattern to what we had before. So there you go, and that's actually not too bad. We're still not breaking into this area here, which is pretty cool. Now we're seeing glitches as they go over, and that's because we're not doing an OR. We're just doing a direct draw to it, but we do have something there, which is kind of cool. So the next step is to probably store these locations somewhere. So I'm going to suggest that we use a little bit of zero page for this. So where we've got these star lookups and bitmap lookups, star lookup I'm going to leave, but bitmap lookup I'm going to move up to 80, and this is where we're going to store all the star information, so we don't have to keep looking it up on the next go, basically. So the way this is going to work is the very first thing that we need to do is work out where this is actually going to be. Think about how to do this. Okay, so it's nice jumping because the length of each increment is not the same for all lines, but it should be. The length of each increment is the same. I'm not sure what we mean there. God, I've got to think about how to do this. This is going to get tricky. So we're looking up the details. This is correct, but what we need to do is then use this value here. We need to store it somewhere. Now, at the moment, I've moved bitmap lookup to here. But that does mean that I need to kind of shift this along. I mean, you would think comma x, but comma x isn't going to do it because x is only increasing by 1 each frame. So maybe what I need to do, rather annoyingly, is this. And then put it back again afterwards, which is even more processing time taken, which I don't like, so I'm not going to use that. Let's think about this. Okay, I'll tell you what we're going to do. We're going to do this in 2 passes. So the first thing we're going to do, we'll keep all that stuff there, but we're going to do 2 passes on this loop. So this is our loop here. And the first pass we'll do using, think about this. Because what we need to do first is clear the current stars, right? So if I take the value here, I'm going to use yes, I'm going to use X index. So I'm going to grab I'm going to go forwards through this, I think. No, hang on. I'm going to go backwards like this. And then that means I can grab bitmap lookup, comma, X like that, and that will grab a value that's at that location. However, the first time I go through this, these values are going to be wrong, so I need to make sure that I fill these values like this. So I need to create a little routine here just to fill these values. Thanks for the follow, NGINX 3D. NGINX, that reminds me of work. And then I Stepz, X. Okay, so this is gonna fill initial values. So what that means is we can then go in here and clear. We're not going to do any ANDing or ORing here, we're just going to clear. So basically, we will load the accumulator with 0 and just store it at that location. So this is going to clear stars. And now to draw stars, first of all, we need to recalculate those locations. So calculate locations. So same thing, going to go through a loop like this again. But this time, what I want to do is I want to think like this. I want to do this stuff, but I need to do it using. I can use a Y to do this as well. So if I use Y, max stars -1. Here, I'm going to put that in square brackets just because it looks a bit. My OCD kicks in a little bit there. I want it to be neat. So then I can do this, this stuff here. So I calculate locations. Yeah, so I need to do this basically. And what I'm doing here is I'm grabbing a star location by grabbing the angles, working out its location here. And then I am going to store that value at sorry, this one here. I'm going to store that value at bitmap lookup for 0, x bitmap lookup just 1, x. That's correct, right? Okay. So that is going to work. Except we're using the Y here, so I need to not use the Y here, or so music stopped. I think the music has stopped, hasn't it? Or something weird's going on. Oh no, something's playing. Right. Okay, so that's gonna calculate the locations for the stars. And then we also need this bit here. And I'm going to store that at star. Do that here. The music's really quiet on this one. I'm going to skip this track because it's a bit quiet. And so we just need to record what we actually need to draw in that location as well. So that's calculating the locations, and then we need one more loop, which is basically going to be like this. Also, that needs to be star loop in there, needs to be star loop in there, needs to be star loop there. I don't know why, it's just because of the way I've copied it, I guess. So same thing again. And now all the drawing happens in one very quick loop, so we can offset a lot of this to happen somewhere else and just have the drawing happen in this loop as well. When do we get to the part with Princess Vesper? I don't know what you're on about. So star bitmask, Y, and store that there, and then decrease Y here as well. And I think that should do it. I'm gonna comment that stuff out there, but hopefully now we should have okay, where the hell am I doing that? That's obviously wrong. strange one. Okay, cool. So it's drawing those stars. It's not using that much processing time. But what we're now no longer doing is this final stuff. Where was it? Yeah, so let's add that in. Okay, so this is moving the star. So let's calculate locations. Let's add it into here. So when we calculate the location, we take the old location and we update it. Which means I don't need to do that line there. Okay, cool. Boom, we've got a Starfield that's coming out from the middle, which is nice and cool. So now let's change the colours. Let's get the colours looking right, because at the moment we're just using the wrong colours. So Starfield would not be on that; it would be on black, right? So let's set the border and background to black. And then when we fill the screen colours in, we'll set the background to black, but the colour to white. So this is going to be the pixel colour. It's going to be the background colour as well. Cool. For a minute then I thought I had turned the sideboards off or something, but okay, let's change the background to blue. There you go. So the first thing I notice is they all come from the same spot, and they probably shouldn't. They probably should come from a little position just outside that. So what I'm going to do, we can mess around with that by changing the values in our tables here. So let's just have a look. So at the moment we're going from 0 to 1. If we change that to go from 0. Hang on, 0 to 1. To 0.8 like that, and then add 0.2 on here. Okay, that's a bit too far out, so let's bring them in a little bit. I think it's still going a little bit more. I think it's just that the last few percent just looks a bit weird when it's coming from there. Yeah, that's pretty good. And you can see how the stars start off slow and speed up, and we can mess around with that as well. So by adding more T's in here, we can make them start even slower. That's a bit too slow at the beginning because we're getting this kind of ring of stars as they appear. So let's knock one more off here. That kind of looks alright, I think. That kind of looks nice. So, the question is, will it rotate, and will it look decent if it does rotate? So we're going to do that by I'm going to copy this chunk of code from here, and I'm going to put that in the update as well. So I'm going to restore that. I'm going to change this to have this. They're not updating because that has become a Y. Okay. Okay, they're updating far too slowly. Let's change this timer to 3.
1, 2, 3.
Yeah, I think that kind of works quite well.
Is there going to be a hyperspace jumping creatures 3?
Is there going to be a hyperspace jumping creature 3? Yeah, that's what this is. This is exactly what I'm doing now. This is just a piece of code for creatures 3. Yeah, and that kind of looks all right, even at that kind of crazy speed. But I mean, it's too much. So let's make this happen as part of joystick control instead. So that's quite easy to do. Basically, what we'll do is we'll put rotate here. And we're not gonna check it every time we go in here. What we'll do is we'll load rotate direction. In fact, we can just do that here, like so. Yeah, that should be fine. And then if we put that variable here, and we started at 0, and then all we basically need to do is whenever we, before we do anything, the first thing we're going to do round about here is we're going to load DC 100. We're going to actually we can use shifts for this, so up, down, left, right. So we're gonna shift the up and the down off, so that gets rid of the up and that gets rid of down. So this is left. So if the carry is set, we don't do anything. If the carry is not set, then we're going to load the value FF, store that at rotate direction. We'll call this joy done. Yeah. In fact, let's do that with X, and then we don't even have to jump. We can just do it like this. And then we're going to do the same again. We're going to shift off to the right, and again, if the carry is set, we don't need to do anything. Otherwise, we load X with 1. And what we can do is if we load X with 0 here, we can get rid of that and that. Just put it there. There we go. So this is our joystick control. And I should be able to spin it around with the joystick, which I can, which is kind of cool. And that's not that bad in terms of performance. That's kind of easy. Now you can expand on this. You could set colors on the screen as well. Use screen RAM to change the colors so they start a darker color here and kind of get brighter as they come out of the screen. You could also use multicolor mode, so you could have different colored stars, which is what I think Mega Apocalypse does, or Crazy Comets, whatever it's called. Change the size as they come closer. That would be a little bit trickier, but not impossible. Not impossible, but it would be a little bit trickier. I'm not going to do that now because that would take too long to kind of figure out how to do. I'm pleased that this has worked anyway. I think I was thinking it would work, and it definitely has. Let's try being a bit crazy here. So let's give ourselves loads of room in 0 page, and let's see how many stars we can get. So we've got enough room here now for 120 stars. Let's try 120 and see what happens. Let's get rid of all of this code here because I don't need that now. Okay, yeah, so we run into all sorts of problems with things clearing here because it's taking too long to process. In fact, is that what's happening? Let me try 64. I just want to see what happens if we just double the number. I think there might be something wrong here. Oh no, it's fine. So can we go to 112? Okay, we reach a point where it's leaking over for some reason. I'm not sure why. Look up. Shouldn't be doing. It should be fine. 112 seems to be too many. Let's try 100. Can you set up multiple starting points instead of just the center of the screen? So all of these points are just from a table. So if you wanted different starting points, you would have to have multiple tables. But yeah, I mean, you could do. So then you would have a different set of tables depending on its starting point, and then look it up from that. So it looks like 100 is too many. Let's try 96. No, for some reason, anything over 64 seems to break. I don't know why. 64, fine. Let's try 65. No, 65 is alright as well. But what's the magic number? Well, I don't understand why there is even a magic number here. Okay, it's somewhere between 65 and 80. So let's try 70. Good night, cheers. 66 is too many, whereas 65 seems to be just right. It's a sign about the Mega 65, that's what it is. Yeah, that works fine. I mean, you can tell it is expensive, because what we're doing is every frame we're clearing a location in memory, then we're working out a new location in memory, and plotting a pixel to it. So it is expensive, but it's a nice effect.
Awesome stuff.
I think it's definitely useful.
We've had multiplexer raster bars, soft sprites, VSP, now Starfield him in heaven.
Thank you very much for the bits, Sam up. And thank you very much, Chiswick, as well. I missed it, Chiswicked. I missed the bits there, so good night, Chiz. I'm sure you've already left the screen, but thank you for the bits anyway. I read the message, but not the bits, so thanks for that. Right, I'm going to go and take a quick break. When I come back, we'll have a play around with this a little bit more. We'll see if we can optimize it, I think. I think that's what we'll do. Oh, you are still there. Good. Yeah, I'm annoyed that Hayes is found. I mean, I was stupid to even think that if I put text-to-speech on there, it would get used sensibly by Hayes. So I'm going to remove that. Jag tonight. No, I'm. Oh god, now you're tempting me now. Damn it. No, I think maybe not. I think I'll save that for the weekend. I like to play that through. I think I'm just going to go to bed earlier tonight. I was napping before the stream, but oh god, that's it. Right. Yeah, I think that's what I need to do. I don't mind it saying the same phrase over and again, but when I have control of that, but to give Hayes the ability to say what the hell he wants, he just abuses it. So Last of Us, no, I'm gonna grab an early night tonight, I think. I'll save Last of Us for next week. Right, I'm gonna take a quick break. I'll be back in 5 minutes now. Let's be right back. Right, I'm back. So one thing I thought I'd add is varying speeds for the stars. So let's go ahead and add a new value into here. So there's two ways we can do this. We can either move the star something other than 1 along the line, or we can delay if that star gets updated. If we delay when the star gets updated, then actually we will improve the performance, because we'll only be updating a portion of the stars, a fraction of the stars every time. So I think we'll go that way. So we'll call it a star delay. And I'm going to add, and for now I'm just going to add either 0 or 1 into here. So we've got 2 speeds, just to test the routine out, and then I'll try and implement it with more than 2 speeds after that. So get rid of this timer now. So we're going to use the timer again to do this. Which means we actually need to do this on every... see, this maybe isn't going to speed it up that much. But let's give it a try anyway. It's just calculating the new locations. That's all we need to do. So we can do it in this bit here. So if we got rid of that, how much quicker would it be? So let's see what we save by not calculating locations. We're not going to see any stars here now, but yeah, okay, so we saved quite a bit by doing that. So let's implement that in here. So what we'll do is we'll load our timer value, and we're going to AND this with our star delay. And if this is not equal to 0, then we're going to skip the update completely. Don't know why they're not indented. And you can see we are taking, sometimes we're using more frames, sometimes we're using less. And that's because some stars will always be using more, and some will be using some less, but not every other frame, every star updates. Okay. So if we want to add additional speeds into this, we need to supply a value in powers of 2. So
2, 3. Outrun.
My last ones. I need to get more. Cheeky smiley face.
Thank you for the bits, Doctor. Very much appreciated. So if we do, hang on, I need to check something. 2. Okay, so what I need to do is I need to grab a random number, like so, and floor it. But then I also need to take 1 from it. So the reason for this is because when you do 2 to the power of -1 is 0.5, 2 to the power of 0 is 1, 2 to the power of 2 is 4, and so 2 to the power of 1 is 2 to the and so on. So I need to do a kind of slightly more complex system here. Number of speeds, but this will basically give you a value that's a power of 2 or 0. We need the 0 in there because 0 is the quickest speed, basically, not 1, unfortunately. Number of speeds 3. There we go. It's actually hard to tell that there's 3 speeds, but well, you can tell from the border flash up here that there are. That's kind of looking all right. I kind of like that. I'm confused as to why this number is what it is. I mean, why does 66 do what it does? Like, why does that happen? I'll tell you why that happens, which means I can fix this. It happens because in these loops here, we're doing branching plus. So 65, if you times that by 2, which we're doing here, and decrease it, it is still going to be positive. So actually what we need to do here is check if this goes. So this would be F. So that's what we need to change all those to. Now we should be able to have more. Oh, it's an interesting one. Oh wow, that's there. That's weird. What? What? Yeah. What? Why? I don't understand that. That's weird. Oh, hang on. We've probably got to do the same here as well. But that shouldn't cause any issues, I wouldn't have thought. No, it was though. There we go. Okay, so let's get rid of the flashy borders because it's kind of off-putting there, and just see how many stars we can add before it starts glitching. So the maximum number of stars we can have because of the zero page locations is 120. We do get a bit of a glitch, and this is because the update is happening while it's kind of in this location here as well. So 120 is too many. So let's try 100. Okay, we still get a bit of flickering over the top. It also doesn't look like 100 stars. I'm not seeing a massive difference between less or more. 80 though, no problem. I'm struggling to see the 3 speeds though. Yeah, because it's ×2. Because we're using zero page lookup to do these to store the locations of these stars. We have to times that value by 2. So but there we go. We've got it working with 80. There is still a bit of a flicker up at the top, but it's not that bad. And we can probably fix that by changing the position here where it actually updates. So if we did this kind of here instead. Yeah, we fix that flick now. Well, it kind of looks nice. I like it. Trying to think what else we can add to this. Actually, I'm kind of less and less liking that kind of ring in the middle, so I'm gonna play with the easing again. Reduce it back down to this. I think that's probably better. It's less obvious now. I mean, the ring is still there, but it's not as obvious anymore. So one thing you might want to do with this is so you can see like the same row of stars happening every time. So what you might want to do is when the stars wrap around, so when they reach the end position, is create a new location for that star, and then it's never going to repeat again. I'm gonna try something now. So I'm gonna put this into the debugger, and I'm gonna mess around with the colors a little bit. So I'm gonna put the background back to black again because it's not gonna work this otherwise. I just want to see if this looks alright, and if this looks alright, then I'll make this another change that we'll do in the. Actually, it's not going to work because this is. Oh yeah, it will because it's screen RAM. Okay. Okay, there we go. Right, so let's put this in the debugger. So what I want to do is I want to change some stuff in screen RAM. So I'm going to come into whichever the screen RAM one was. It's this one. How on earth do I do this now? Forgot how to bring up the fonts. Oh, that's not what I wanted to do. Okay, tell you what, I'm going to do it manually. Okay, so we're going to fill the screen with that color, and then I'm going to make some little squares of color in the middle. So I'm going to do this, but I'm going to change the middle now to. So what would be the easiest way of doing that? In fact, do you know what I'm going to do? Do you know how I'm going to do this? This is how I'm going to do this. So I'm going to open up Chartpad. And then we're going to define some characters in here. Now the character set doesn't matter, but this is what we're going to do. We're going to draw letters in here. So this is going to be black because it's at 0. This is 1 0, so this is going to be white, which is what I want to fill the screen with. It really doesn't matter if it's needs one. I mean, that's the worst W ever drawn by a human being. There we go. And then I'm actually going to set the background color, and I'm going to set these colors as well, just so it's easy to see. Black, I'm just going to... Black really doesn't matter, but white, I want to see. Oops. And then we need a grey color. So greys are at C0, B0, C0, and F0. So the next one is going to be F0, which is going to be this one here. Which is going to be, I'm going to give these grades instead. So this is going to be 3. B0 is going to be, well, C0 is going to be here. This is going to be 2. And B0 is going to be here, which is 1. And then all I need to do is set these colors. So that's going to be like that color, that's going to be that color, and that's going to be that color. And then I just need to kind of draw these out a little bit. So I'm going to create a kind of circle of grey in the middle, like so. Doesn't need to be accurate, I'm just testing really, so as long as it's kind of roughly circular, it's fine. That'll do. Then I need the slightly lighter grey, dark grey even. I'm going to make that a little bit bigger, but essentially fill in space like that. And then the darkest grey is going to be right in the middle here. Right. And I'm just going to export that map, and only the map. And I'm going to put that into Starfield. I'm just going to call it map.bin. It doesn't matter what I call it. And then I can just draw that directly into the screen. So import binary map.bin. And now I can get rid of this here because I don't need this. Okay, why did that happen? Well, let's move the screen up then. Let's move the screen to okay, we've got the bitmap at 2000. Can't put it at 1000. We can put it at OC100. That's here, like so. And then all we need to do is relocate the screen RAM. So this is this bit here, which is going to be, so this is 0400, this is 0800, like that, and so that's OC. So that should be fine, I think. And so now the stars start kind of darker and get brighter as you come out, and that looks a little bit better. So I like this tune, whatever this is. Dutch Breeze. Yeah, I've heard this before. I like this. If you do not notice a big difference when increasing the number of stars, isn't because the number of positions on the line is not large enough, so you end up having many stars at the exact same position. Yeah, I mean, it's a possibility. Also, there's always going to be stars that are kind of off screen as well. So the stars that are down here, you'll only see when we rotate. So yeah, that kind of looks pretty nice, to be honest. Thanks for the follow, Wade Watts. Welcome to the stream, dude. Isn't that 1K? What are you on about? Draw a big crosshair over the middle to hide it. Oh, you mean the circle in the middle? Yeah, I think that looks kind of neat, to be honest. I think the extra color just adds a little bit to it, and you can play around with the colors. Obviously, I mean, I've just thrown this together in here, but you can see the point. I'm creating a map that that basically colors the stars as they move out towards the edges of the screen. So you could mess around with that quite a bit. I mean, you could even have it so that you know, the stars go yellow as they pass through a certain point, maybe on the outside, like right on the outskirts here, they go yellow. So if I wanted to do that, that would be this one here, which I'm going to put a little Y into and make it yellow. So I could just kind of colour the edges around here. Oops. Actually, this whole thing seems to be slightly off-center, doesn't it? So let's see if I can move the whole map over. Ah, there we go. I mean, it's really skewy, but I mean, you could spend some time and tidy this up, make it look kind of neat, but it'll do for the purposes of this. With redshift, you need some red in the corners. That's a good point, actually. But yeah, you can kind of see them going yellow. The ones that kind of hit the corners go yellow. So if we wanted to change that to red, that's easy enough to do. Again, just going here. So red would be this one here. Oh my god. There we go. The colours that I set these really don't matter because it's just the screen data that matters here, and that's this row of columns here. So this is the colours down here. These are the background colours as you go across. Yeah, so there you go. The ones in the corners are kind of briefly going red just before they disappear off screen. That's kind of nice. And so the considerations for this are a few. So the first thing is the more stars you have, obviously, the more raster time this takes. But generally, if you've got a Starfield like this, you're not going to be drawing a map over the top. You're just going to have some sprites over the top, which means you probably at the most have a multiplexer on. So really, having this many stars isn't a huge problem. The other consideration is memory space, obviously. So with the bitmap, you're going to use half of your VIC bank straight away, just for the bitmap. So that means if you... and you still need screen RAM in there as well. So that only leaves 7K for sprites, which means you've got about 112 sprites, I think, to play with, which is still a lot. I mean, you can still do a lot with that. But also, the problem with this is you probably are going to end up using sprites for your border as well. Sprites for your HUD and stuff. And I think that's what games like Crazy Comets and stuff do. They have sprites that are the HUD up here. So you will be using some of those. I mean, worst case scenario, you'd probably have a HUD up here and a HUD down here, 8 sprites in each. So that would be 16 sprites, which would still leave you with 96 sprites, which is kind of plenty. The other disadvantage with this method is you're kind of limited to either using sprites as bullets or using the bitmap as bullets. Now, if you use the bitmap as bullets, you need to do a similar thing that you've done with the stars, but with bullets as well. It's a little bit simpler because bullets are generally going to fire in the same direction because you're rotating the star field rather than the ship itself. The other problem, of course, is with rotating things like this is if you are using sprites for enemies, you kind of need to rotate those as well. So I think what a lot of them do is they'll have a couple of versions of it, maybe not a lot, maybe 8 different rotations, and they pick the closest one to the angle that you're at and draw that. But this is obviously going to be quite limiting. The other thing as well is the memory used by the star table itself. So by changing the resolution of the star, so how many different points they can be along any line, and how many angles you have, you increase the table. So we're using 8 kilobytes for this table, and that gives us 64 positions for a star along any given line, and 32 different angles that you can go to. So you could reduce the angles, but obviously if you reduce the angles, the rotation is not going to look as smooth. If you reduce the positions along the line, then the star movement along that line isn't going to look as smooth. The other thing to note as well is that we're using zero page for this. So we're using zero page to store, for speed purposes, to store the address that we're going to go to. So that we're going to change on the bitmap. Now you could move this out of zero page. You'd have to probably use self-modifying code in these loops to do that, which would free up some room in zero page, but that would come at the cost of performance, obviously. So it's kind of about finding the right balance for what you want to do. The good thing with this is that you don't have to draw a map. There's no map to draw. So if you don't have a map to draw, you save some memory there. So the memory you would normally use for maps, you know, for tile data and character data, is probably what you're now using for storing these tables. So it's probably an okay trade-off then. The biggest problem is going to be the zero page stuff. I think you would probably want to reduce the Starfield down to an amount that still looks decent. So like if we went down to 48, I think it would still look pretty decent. It's just not going to look as full as this. And there's other tricks as well to make them look more full as well. So so here's a 48 star Starfield. If we were to change the tweening on this to be almost linear like that, I mean it just looks odd, unfortunately. But you should see more stars on the screen because actually no, you're going to see less. I think if I put more of these in, so if I do 5, I think you'll see more because they spend longer in the middle. Yeah, the problem is that they get stuck here then. So actually, another way, let's try and fix this issue. So this is happening because this is deemed the start point of the animation, and with this animation, they spend a long time at the start point. So instead, what we're going to do is we're going to make the start point in the middle, but they're always going to start somewhere outside of that. So they're never going to reset back to 0 again. So let's see if we can do that. So this is the routine that we're using at the moment. So if I do 1 and get rid of that there, let's keep these values in so you can see how to kind of adjust them. But this is going to make things start from the exact middle again. But we would like them to start a little bit further out. So what we can do is when we're working out positions, so e's in quart, blah blah blah, j times 63. So if we just change this and we do we add a value here, so if we add like 5 to here, but then also add 5 to this side as well, what we're now creating is an animation where they start a little bit further out. So we might need to add a little bit more. So let's try adding another 5 to it. Another 5 to it here. Means we can get rid of this bit here as well. Let's get rid of that for now. And that looks a little bit better there. They're not starting quite in the middle. So I'm gonna put this value in here. I'm gonna call it spawn offset. So I'm going to make it an adjustable value. And then in here I can do 63 plus spawn offset. And so if I make that like 15, they'll start a bit further out. They'll start further along the line. So thanks for the follow, Zeeth. Welcome to the stream. Oh, and hey, Pixel Drama Club, welcome. Why has that not worked? Because I put the wrong type of bracket in there. In fact, there shouldn't be a bracket at all there. So I think the problem is this using a quint kind of keys is probably a bit too much. So let's try a quad. They should start a little bit more. See, they're not starting outside. That's weird. So they should be doing. Maybe the offset needs to be a bit further along. Let's try. Well, let's try it with this one, and then you should be able to really see where they're starting. Okay, so yeah, they're definitely not starting in the middle anymore. So let's ramp that. Whoops, let's ramp that back up to that, and let's change the offset a bit more. So if I did offset like that. Cool, okay. That feels a bit more natural than it did before. There's less of a ring kind of thing happening in the middle. So by changing this value here, you can change kind of how close to the center these things spawn. Cool. Right. Multicolor stars. No, I haven't done multicolor stars. But I mean, it's an easy enough thing to do.
Last bit's him off for 3 weeks, so you all in 3 weeks. Thanks again for the nice.
Oh, cool. Have a nice break, and I shall see you in 3 weeks. And thank you very much for the bits again, Emma. Pretty damn fast for bitmap, at least warp 3. Can the stars be 4 times as big? So yeah, I mean, this at the moment this is just using a very, very simple way of doing this. But what you could do is you could increase this value here. Yeah, I mean, the thing is you'd have to do some calculations here to make this work properly. The problem you're going to have if you just try and make the pixels bigger, then you're going to start running into issues with pixels that kind of overlap different areas. Now we could turn multicolor mode on. That might be enough to do it. So if I did that, which is in D016. So if I just set the value of D016 to be bit 4, so if I make it D8. I have no idea what this is going to look like in terms of colours, though. That's the problem. Yeah, see, we get weirdities because now what's happening is as the sprites, as the pixels move, they're actually there's flickering between different colours. So you'd have to fill the video RAM. Let's try actually. Let's go in here. I know it's not going to work because. What would you have to do? You'd have to set all the color RAM the same as you've set the... Yeah, or you would have to make sure that the bits... Let's have a look. I think if I did... If I did that, I think that might actually fix it. No. Because that's setting The problem is you need to set 2 bits basically instead of just 1. So it would have to be. It would have to be like this, I think. I think this might work. Let's give it a try. Yeah, I mean it's not quite right, but it does make them bigger. But yeah, I mean you would have to kind of play around with these routines, and it's kind of a little bit beyond the scope of this to kind of mess with that now. Joystick forward to speed back up and slow back down. Ah, that's interesting. How could we do that? Just trying to think that's the easiest way to implement that. So that would be trying to think, because you could do it with missing frames, or you could just speed these up. So let's just try speeding the stars up themselves. So let's put so where's our little joystick routine? Here it is. So this is up, this is down. So let's do this. So this is left and right, up and down. So speed wise, you don't want the speed to increase too quickly. So I'm going to first of all speed, otherwise I'm going to do this, and this will be do left and right. So we still have to pop those values off, even if we're not going to use them. Otherwise, we can use them in a different way, which is what we're going to do here. So we will grab that. If it's not set, we're not pushing up. We're going to load accumulating speed. And we'll cap it, so max speed in here. Let's call that not up. Branch if not equal to here. Otherwise, we're going to load accumulator. Well, branch if set. So if it's more than this, so we'll just make sure max speed gets put in there. I'll store that at speed, and then down is basically the opposite. So call that not down, and this time we'll subtract. If it's still positive, we'll go to there. Otherwise, we're going to load it with 0. Then we're going to create a max speed variable. Well, max speed label. Let's make that 4. And then when we do the update, the stars. So when we come to, so this is clearing the stars. Let's get rid of that. Calculate locations, here we go. So this is where we do the angle and we do the done rotate, and this is where we do the oh no, that's where do we do the start positions? There's the start position. Okay. Star delay, skip update, add speed. There we go. And that would be like so. Okay, it's constantly rotating. Why is it constantly rotating? Was down. Uh-oh. Down. Oh, because we're actually destroying the accumulator here. Okay, so that's why. Hot and speed on the stream, yeah, indeed. Still rotating though. Why is it rotating? Let's just cancel this out for a second. Which would be that like that. I just want to make sure it's all working before I quit. Okay, that's fine. But for some reason, if I start... Oh, it's this again. Damn it. Okay. Okay, I'm just going to cheat. I'm going to push it there, I'm going to pull it there. God damn it. No, this isn't going to work, is it? Oh, do you know what? I'm just going to store it in joy. This is why I like to have a joy variable in here somewhere. I'll do it here. Oh, damn it. Some of these tunes are really weird. I don't know what this tune is. Oh, somebody requested Gyrus. Amok requested Gyrus on his left. I missed that request. I didn't hear the text of speech. Damn it. Sorry, Amok. I will make sure I play that next time for you. I'll reject it for now and then you can do it again. I just thought somebody was saying that the game looks like the Starfield looks like Gyrus. Okay, I think the acceleration is a bit much, so let's put that to 1F. Let's do 3F. It should be quite slow, I think. And yet that happened really quickly. Why does that go to full speed immediately? Perhaps that should be CC, that's why. That's why, right, okay. Cool, so we can mess around with this a little bit. I'm going to put this to 0F. I'm going to change max speed to 8. Cool, there we go. I think you probably do this with timings rather than... So I think you just have stars moving really slowly. Like this is too fast probably. This would be slower than this. but it kind of works. I'm going to make minimum speed 1, so you always start at 1. And then I think I'll call it a night there. I think we've done all right tonight. I'm pleased this worked. I mean, this was, as I say, it's the first time I've ever done this. I don't know if this is how other people do it. I've not looked in any detail. I imagine it's fairly similar. What am I looking at now? Speed. Okay, speed. Compare X. Okay, branch if not equal there, otherwise. Right. There we go. So you can't go any slower than that now. But max speed is proper hyper speed. And again, that's with 48 stars. So I'm gonna get the maximum number of stars I can get in without it glitching, and then I'll call it right. So let's try 100 again now that I've moved the raster to a different location. Still a bit flickery. I mean, it still looks all right, and you might want kind of flickery stars anyway. But unfortunately, they flicker in the top half and not in the bottom half, so that's a bit weird. Let's try moving the raster up a little bit. Just like move it to the middle, see what happens. Okay, yeah, it's clearing the stars immediately. That's the first thing it does, is clear the stars. So that raster does kind of need to be down at the bottom here. So I think F2 is about the latest you can do it, the earliest you can do it. So let's reduce the maximum stars to 64, which seemed to be a nice number that we were hitting. In fact, let's put these values up at the top so easy to find.
One, two,
Yeah, there we go. That's kind of looking good.
outrun. One,
Starfield.
Thank you, Doxer, for the bits. I'm gutted I missed Amok's tune. But yeah, there you go. Rotating Starfield. I was a bit worried when I started the screen that it wouldn't work out. That's why I did a bit of preparation trying to work out the exact formula for kind of plotting pixels, X and Y on the screen. And while we're not using that directly, we're building the table based on that. So it's a handy little macro to have if you want to build tables for these things. But yeah, quite pleased with that. It's turned out okay. It's turned out all right, hasn't it? Interestingly as well, I just want to try this before I go. If we mess around with this value here, so this longest value, so we had to work out where the edges of the screen were. If I change that value to something smaller, we'll get a really tiny starfield in the middle. So this is a starfield that will reach the top and the bottom of the screen, but nothing else as well. So you could even, you could even go, and they will look smoother as well. The smaller they are, the smoother they'll look. So if you wanted to kind of split the screen up a little bit, you could do it like this. So it doesn't look that much smoother, but yeah, there you go. The problem is here now is they're all being drawn in the bloody middle. Yeah, okay, cool. I'll leave it there. That's it's not that much code. The bulk of the stuff here is the tables. The tables and the bitmap alone take up 16k. All right, let's have a look who to go and raid. So I will, as I say on the giveaway, I'll add a couple of tapes in there as well because it looks like it looks like we're looking at enough people to be able to. Yeah, let's put the raster time thing in. I'll leave the background raster thing in so you can see immediately. It looks like we're looking at enough people to actually justify adding some tapes in there. So I'll add. Where's the loop again? Where is it? I'll add a handful of tapes into the collection as well. No, it's not. It's not that bad, to be honest. You've still got a lot of time there, and if you consider like a scrolling map, this is not that bad, really. And you could do some clever stuff. So, like, you could alternate the frames that you update the stars on. So you could do one half of the stars on one frame, one half of the stars on another frame, and then you'd half the amount of time it takes here. You'd get a less frame rate, but you could easily kind of reduce this more. Remember, we're updating all 64 stars here every frame. Right, let's have a look who we can raid. Yeah, so as I say, I will be doing a giveaway, not this Saturday, it's probably going to be the Saturday after, because I need to make sure that the stuff has come, because I want to show it on the stream. But I will make sure... Oh, Chinese Hulk is playing. What's he playing? It's got to be Mario, isn't it? Oh, no, it's not. What's that? I'm not sure what that is, but we'll go and raid him anyway. Could you have had that in the 4K competition? No, probably not. Actually, no, you could probably generate the tables at runtime, but it would have been tricky, I think. I don't think it's impossible, but you could probably have squeezed it in somehow. The table is 8K, so you'd have to generate that at runtime somehow, which wouldn't be the easiest thing to do and probably would take quite a bit of code to do, but you could do it. There's no reason not to. Alright, cool. So let's go and raid Chinese Hulk, and I shall see you guys on Saturday. We'll get some more game stuff done. It's looking really good, the game now. We're getting into a polished phase, definitely. Okay, cool. Right, let's go and raid him. I will catch you guys on Saturday then. Take care.